Thanks for attending this webinar on nCodeDS, a new product we just released, part of Akira 2019. And this webinar is called Actionable Insights from Digital Streams. So what I suggest is we start with a short introduction on the company and the products. Then we'll cover what's new in Akira 2019. And one of the topics, as you'll see, is the Python runner, which is really helpful. We'll discuss some applications, and part of the Python runner, we'll see that we have nCodeDS that's usable and which has a number of benefits, and particularly for processing huge quantities of digital data. And to show you this live in practice, I'll do a couple of demos, and then we'll go to the question and answer section at the end. So let me start with a quick introduction on Prensia. So who are we? So basically we provide software. So we have two brands, nCode, the nCode brand, most famous softwares being GlyphWorks, DesignLife, VibeSys, etc. And we've got the ReliaSoft brand with softwares for reliability analysis. We also provide training, education. So since we are experts in durability and reliability, so not only can we provide this software, but also training, education, and services. We've got, for instance, a material testing lab in the UK, and we can work on various projects like solutions for design or solutions for asset management. So that's us. That's Prensia. I personally work for the nCode branch, and we'll discuss here what we have in nCode and particularly Akira here, and you'll understand why in a minute. So typically, as an engineer, you are to process some data, whether it's coming from the test, some like the measurements from the lab, or some full-scale tests, or from simulation. So you get a FE results file, for instance. So you typically run one of our desktop tools, so DesignLife for CAE-based fatigue analysis, or GlyphWorks for signal processing durability analysis, VibeSys for more of the vibration and acoustic side of things. So that's one possibility, where you get this desktop software installed on your machine and you work locally, interactively on your machine, right? The other possibility here is Akira. So here we more talking a server-side software. So there is a web access. So Akira gets access through the web. The nice thing about Akira is you can easily create apps, which means you can hide the complexity of a workflow, a GlyphWorks or DesignLife workflow with those pipes and options and properties and stuff. So you can hide all this. We'll see that in the next slide in practice, what an app is and its benefits. You've got data search and indexing now in Akira 2019, which can be very interesting for a company sharing data. And of course, a server is typically more powerful than your local machine, so you can take advantage of the server-side power for your analysis. We've got license management. So not only do we manage the tokens, but also Akira provides some benefits, especially for international or multi-site use of the Prensia software. The last topic here with Akira is nCodeDS. So that's for streamed analytics. So that means you can process measured data, sensor data that may as well come from the lab and test measurements that you see here on the bottom, or from connected equipment, from digital bus type data. So that's typically low quality data in comparison to the sensor data you're getting from the data acquisition systems. It's typically not meant for test and measurements applications, but they are so easy to get, and they can provide us so many interesting insights on particularly the usage of a product that it would be a shame not to use them. So with nCodeDS, and we'll cover that in this presentation, we can process this type of data very easily. So in conclusion, just in Akira, using Akira, you get nothing installed on your local machine. Everything goes through the web. It uses the power of a server that's so sits somewhere in your company. You have a friendly way of using complex analysis via apps, and you get additional features such as data search or this brand new EncodeDS that you can use. So I mentioned apps. Just allow me just to go through that slide. I think apps are really, really important for for spreading or for deploying an analysis that you've created. You, the expert, say you create this analysis that you see on the screen. It's really, sophisticated. It's really good. It's exactly doing what you want in terms of optimizing your structure, for instance, in this instance here. But it's not everyone can use it, say. So the idea is to use an app to deploy that, so that the user, when clicking on this app, will have a few questions asked, such as pick an input file. Then it'll have to answer a few options, other questions, to do with properties, so the duration of the excitation, the material, things like that. So that you get a selected number of options that the user has to answer to, and there you go. You get your answer. So that's basically illustrating what an app is. So it's masking the complexity of, or the potential complexity of a workflow, right? So Akira 2019. So Akira 2019 has been out like 2 weeks ago, so it's very recently out. Before I list the main new features, for those of you who are not familiar with Akira, there are a couple of webinars that we made on Akira, and you can find them if you visit our website, the nCode.com website, or Pretsia website. Under resources, you'll find webinars, and at the bottom of the page, you'll see the archived webinars. So if you're not familiar with Akira, just check it out and see what's there. So in Akira 2019 now, so we've got a CAE viewer, which is a new way, far more efficient way of looking at FE models. It's much faster in your web browser than it is on your local machine, thanks to the CAE viewer. So this, with the data search, will be the topics of future webinars. But so data search is also a new feature. So you can index data, and then you can easily find any data, whether it's a channel or test or file. But what we will insist more on this presentation is the Python runner. So that means more flexibility in your apps. We'll cover that in a minute. And with the Python runner comes nCodeDS, which is a brand new analysis capability. And we'll see all the benefits of using, well, you should use nCodeDS when it comes to processing large quantities of sensor data, right? So we'll insist more on the two last topics here. So let's start with the Python runner. So for those of you who are familiar with Akira apps, we've got here the guts, or the details of an app. This one is made of 3 components. The first component is called data files, so you select which files you want to process. The last one is a display component, and the middle one is a new component that's available to you. It's called the Python runner, right? And so you can drag this Python runner, and it offers you an editor, scripting editor here, where you can write your code, right? So the idea is it offers you endless opportunities and flexibility, and you can create any process, any analysis. Typically, use advanced logic. Once you get a hold of the files that the user has selected, you can further filter down what you're after, things like that. In terms of creating your script here, it's got colored syntax, and so it's really easy to use. You get the interrogate script that tells you if anything is wrong in terms of the indents and things like that. So it's very easy to code directly in this window, right? And so Akira 2019 gets shipped with Python 3.6 and also some modules such as NumPy, for instance, numerical Python. But there's nothing stopping you from importing additional Python modules, right? Now, one of those modules is provided by us. It's called nCodeDS, and it's basically a processing framework that you can use and call its functions or processing functions in the Python runner. And we'll cover that into more details in the next slides from an application viewpoint, right? So, why did we develop nCodeDS? What are the challenges we were facing, or you customers are facing? So first, I guess, is the quantity of data. Nowadays we constantly hear about big data and or Internet of Things. So it's the cost of getting hold of data is constantly reduced, right? So we get more and more easily access to large quantities of data. So when it comes to applications like customer usage or fleets of connected vehicles or generally speaking, connected equipment, so sensor data from connected equipments, for those kinds of applications, you very easily snowed under with large quantities of data you have to cope with, right? The other issue is the variety of data. So not only do we use only clean high quality data from a data acquisition system, right? An HBM, Quantum X, or SOMAT, or more and more we also want to use data coming from digital buses, for instance, or data extracted from data lakes, big data historians, data coming from online databases such as weather websites. This sort of data comes maybe as text file as opposed to nicely consolidated binary files, that we recognize natively. So the data is very coming from different sources can be very different, and we need to be able to cope with such data. And often the data coming from digital bus is time stamped as opposed to nicely evenly spaced data, right? This data from digital buses is sparse. Often it's compressed. It's got error codes and all sorts of stuff that we're not used as test and measurement engineers. We're not used to see. It's got like not a number, an NaN in there that we need to cope with. So that's on the variety of data. And the third bullet point here is the need for high performance analytics. Before I mention I'll go more into details with what I mean by high performance analytics. I'd like to say a word about the quality of the data. So like analytics, it means, in other words, it means getting knowledge from the data. You wanna get insights so that you can make decisions, you can make actions from what you've learned in the data. If the data that's coming in is wrong, has anomalies, it has holes like missing data and things like that, if you're not careful, the decisions you're going to take may well be based on wrong results, right? So it's very important to take care of the data quality first. So run a pass of anomaly detection, run a pass of to process those not numbers and all those issues that we find very easily, unfortunately, with digital bus data, with non-clean data coming from data acquisition system. So now analytics. So the engineer that you are is after some statistics, some countings and trends and spectra, and you may want to compare before and after, or even you may even be after more advanced stuff like the accumulation of damage with time, or on a per event basis, or on a per day basis, or some fancy data science algorithm based on machine learning, for instance, neural nets, whatever. So you need this. You need to apply all this on loads of data that's very heterogeneous, right? So, and you want this to happen, to occur at a very high speed. So those are the challenges. Sorry, I've been a bit long here, but just to set the scene and make sure you understand where we're coming from, right? So now nCodeDS, we believe, is the solution to those challenges, right? It's a server-side, scalable, it's elastically scalable processing tool, and it comes with Akira 2019, so the latest version of Akira. It's ideal for the batch processing of huge time series data sets. By time series, I mean just sensor data, the x-axis being time, whether it's evenly spaced or not, it doesn't matter. It's generally called time series, right? And so nCodeDS in Akira offers those files can be distributed and processed in simultaneously, so it gets really fast. Again, the data can be unevenly spaced, doesn't matter. It can contain nans, not a number, gaps, etc. So that's the sort of data that comes typically from connected equipment, like connected vehicles, right? But any production plants or whatever, machinery, connected equipment in general. Within nCodeDS, we have a wide range of analysis capabilities. We'll cover that in the next slide. And it's accessible via Akira, simple to use, thanks also to the possibility of using apps, making it really simple to use. So not only is it simple to construct a processing network with nCodeDS, but it's even simpler to deploy it throughout your company, and that's really important, I believe. So your data scientists, all this is you remember the Python runner. Python data scientists love Python, and so do some of the expert engineers, experts in data processing. So this very flexible tool can be used by data scientists, by your expert engineers, and can be then deployed through the company. So the idea is, from large quantities of sensor data, you now can easily get to metrics, indicators, whatever that enable you to make engineering decisions very easily, very fast, right? So a few details about nCodeDS, right? So as I said, it's a data processing framework, and in its first version, in Akira 2019, it comes with a number of features. Let's start with the file format support. So in its first version, we read the S3 and we write the S3 file format. So for those of you who are familiar with GlyphWorks or Design Life, you know what an S3 file is. But we made sure the CSV file, so text file more generally, come as separated, or text files, containing columns of data is really easily accepted in input and saved in outputs. But we have another list of file format that we read natively, so that's the HBM bin file, MTS, Encode DAC, etc., SOMAT, and this list will get longer with the mid-year release of Akira, so the version 2 of nCodeDS. In terms of processing now, so let's start with the anomalies. So we got limit detection, so every time your sensor goes in saturation, for instance, spike detection, and in terms of manipulation, we can correct, for instance, for those anomalies using the mask, the fill nan, the drop nan nodes. We've got a column splitter to separate the various columns and do separate analysis on those, a row splitter based on the condition. You've got some sections of data that are separated from the rest. And on those sections of data or columns, you can do some signal processing like arithmetic, whether it's global arithmetic function or cross-column calculations. You get a filter, you get a way to produce FFTs, PSDs, differentiation integration. And we wanted to have some stats, so we've got running statistics, global statistics, and we've got amplitude distribution, so like probability density functions, or whether they're cumulative or not, so to see how your data is distributed. In terms of fatigue analysis, that's a key differentiator to us. We do have strong expertise in this domain. So we got a rainflow cycle counts algorithm and some relative damage nodes as well that you can use. Last but not least, if there is in this list something that you really want to use and it has not been listed here, you can use it. You can use your own Python code, so you can benefit from the framework, the parallelized, highly efficient framework for processing, very efficiently large amounts of data, and create your own node in there containing your own Python script. So that makes it very, very, very flexible. So if you decided to get started tomorrow, say, where would you start? I suggest you'd start with the cookbook. It's not online as I speak, but it will be online very soon from our website. It'll contain examples. Here's a screenshot with very taking you by the hand and going through those examples with example data that's provided, input data and expected results, etc., step by step. But you also have the nCodeDS Programmer's Guide with all the details you want on every of those algorithms, from the input node to the processing nodes and the output nodes, and the Python node as well. So loads of help, from beginners, how to get started with the cookbook, to experts, knowing exactly what this option, this property is about. Right. So let me just come to some sort of conclusion here. So the main points of nCodeDS. So the first one is about extracting more value out of sensor data. Whether this sensor data comes from a DAC, data acquisition system, or a digital bus with unequally spaced data, it can be extracted from big data, cloud storage, data lake, whatever. We still can use this data and extract information, insights from it. The second bullet point is nCodeDS is a powerful, scalable, distributed stream data processing tool. So that's ideal for processing large quantities of data at a very high speed. But it also has it's not just about speed. It's got also loads of very fancy, sophisticated algorithms, especially when it comes to our field, our domain of expertise, which is durability. The third bullet point is nCodeDS is included within Akira. I think that makes it very, very useful because it's, as I said, easy to deploy via an app. It's easy to use via an app, right? So not only do you share the data, you share the app itself, you share the results. So that makes it a whole, an integrated engineering environment and not just a processing tool, right? So I guess this is a fair conclusion. Well, on nCodeDS, right? The three main points. Now we move on to the demos, live demos, so you can see in practice what I mean by all this, right? Before I switch to my web browser, my Akira system, running some apps, let me introduce you to the first demo. So first, the problem statement. So I'm an engineer, right? I'm a test and measurement engineer, and I've got more and more of those test and measurement data. And I'm asked to process more files with more channels at higher sample rates. So I wonder, how can I get durability results faster on this large number of test and measurement data files? So here, we're not talking digital bus data, we're not talking data lakes, whatever. We're talking, the usual formats, usual files that we get from our favorite data acquisition system, whether it's Perception, high speed, or LanXI, or HBM Quantum, or SOMAT, EDAC, whatever. And we want to process that and get the results as fast as possible. So the answer is, guess what? Encode ES. It provides highly parallelized stream data analytics, as we'll see in a second, right? You can increase the performance by increasing the number of threads, because it's parallelized, the processing is done in a parallelized fashion. The more threads you have, the faster it'll go, right? You can also increase the number of parallel executions. So especially if you're working with files, different files, each file will be processed like simultaneously with the next one, right? Different parallel executions. So the example I'm going to use now, I'm going to use an S3T file, which is 370 megabytes, so quite heavy. It's got 82 channels, over 1 million data points each, so that makes it roughly 100 million samples in total, right? So let's now run an analysis, an nCodeDS analysis, which does a bit of everything, a bit of cross-channel calculations, channel splitting, and depending on the sort of channel, we might want to do filtering and PSDs, or more rain flow cycle count and damage and things like that. So let's now have a look at the system here that I've got. So I've got an Akira demo, Akira system here. So let me log in with my credentials. So I used my credentials here, so it knows who I am. I've got my own dashboard that's updating now. I've got my own flows and apps, my own apps, or the apps that have been shared with me or with the group I belong to. So let's jump straight there to the app list. So here there are 3 apps, 2 that I've created. I'm the owner, at least, for them, and 1 from someone else. Let's imagine the list is longer here. You can filter. So I just want the Fred's apps, and after this app that does what was it? Rain flow, right? So up you can filter it down. Now I've got just 1 app here, and that's exactly the one I'm after, right? The one that produces rain flow and PSD on an S3T file. So I've pressed the run. Sorry, I went fast here. I realized there was a run button on the right-hand side. Sorry about this. And once you press run, it's now loading the first page, which is typically a list of questions for the user, right? So the first page that got loaded here is the file selector. So it's asking me basically to select which file I want to process. So I'm just going to select one here. So that's the 370 megs file. I'm pressing next, the next button on the top of the screen. So far so good, very easy. And now what's going on is that the server is working for me, so nothing's occurring on my machine in terms of processing. Everything's done remotely, close to where the data sits. And here you go. So I've got my rainflow cycle count for my first channel, for my second one, my third one, and etc. for my 80 or so channels, right? And I've got on the top right here, you've got display PSD. So that's a custom button that I decided to add as the owner, as the creator of this app. I thought for my users, it would be nice to have dedicated buttons that are very explanatory, self-explanatory. So display PSDs. Let's click on that. And now you've got a set of spectra that are displayed. Again, I'm just showing 4 them there. That's by virtue of so that's how I created the app, but I could well display tens of them if I wanted to, or just 1 or whatever, or add additional buttons, display the PSD of this very channel or whatever. And I can go back to the rain flows. Once I get this, I can copy to clipboard, print, This can be saved. Actually, it is saved in my own user space in the system. So anytime I can download it on locally, or point to it to a a colleague of mine, look at this data in there, whatever. So the results are now available. So that was basically the first demo. Let me go back to the presentation here. So the takeaways from that demo. As we said, nCodeDS provides highly parallelized streamed data analytics. You didn't realize it, but it went really, really fast. It was like 5 to 6 seconds to process this large file and do all the processing algorithms that I mentioned. If I used the same file and if I did the same thing in GlyphWorks, it would have taken 54 seconds. I'm not criticizing GlyphWorks here. What I'm saying basically, GlyphWorks is a great tool, and I'm sure most of you know GlyphWorks and appreciate. I hope, because I'm product manager for GlyphWorks as well. So I hope you appreciate GlyphWorks for its interactivity, the ease of use. You drag and drop, you display, and you run and change properties and run again, etc., till you have the workflow that you were after. So that's GlyphWorks, but it's a desktop tool. It's got its pros that I just mentioned. When it comes to processing, tons of those files at a high speed, and you're after pure processing power, I believe nCodeDS is the solution. So in this case, the performance comparison shows at 10 times that nCodeDS is 10 times faster. 10 times, right? That's huge. And it could be even further accelerated if I were using more threads. Here I was using four of them, and it could be even this figure here, this 10 could be even higher if I had used several files, because of the distribution, right? All those files would have been potentially, depending on the number of queues you have in your system, but it could have been potentially run in parallel. So a good question, let me just pose that. A good question first is, how come nCodeDS is 10 times faster? What do you mean by streamed processing, stream data analytics, and things like that, this stream bit? Let's see that. Let's first start with GlyphWorks. Let's remind ourselves how GlyphWorks works. First, it's serial processing. So all the data is loaded into each glyph, in a sequence, sequentially. So each glyph processes the whole data before moving onto the next glyph, right? So that's illustrated here. The whole content of the input file gets processed in the first glyph, then in the second, then in the third, etc., right? Let me just run that again. I'm not sure it renders very well via WebEx. So it's a glyph by glyph processing of the whole data, right? That's GlyphWorks. So now in comparison to that, we'll look at the way nCodeDS works. So now it's parallelized streams, so which means the data, the input data, is broken down into chunks that we call frames, and each frame goes in the next node, the equivalent of a glyph, right, in the next algorithm, and so that enables us to parallelize the whole thing. Let me just run it again here so you get the whole data here. It gets broken down, and each chunk goes to the next node, while the previous node is processing the previous chunk, etc., etc. So that explains the streamed word. It also means that if the data is not, if the input data is not available as a file but as a continuous stream, it would just work, right? Because of the framework, the way the framework is designed. But here my point is this way of processing the data makes it potentially much faster. And as we saw with standard S3T files, it can go 10 or even more times faster. Right. Now I also mentioned another thing, this parallelization, this distribution of files. So say you've got 4 files here. You've got file 1 to file 4, and say your system was the Akira system you have has those 3 processing queues, if you like. So file 1 goes into the first one, file 2 there in the second one, file 3 in the third one, each one running the same process, right? So file 4 will go queued after file 1 there. And so all 3 executions will run simultaneously now, so that we get the results from the file 1, 2, and 3 simultaneously, right? So in other words, it can get 3 times faster. And then file 4 is processed in the first execution there on the top. So that's the file distribution in Akira, right? Providing even further acceleration or performance. Okay, I hope this was clear. I'm not going too fast, hopefully. Let me continue with the second demo. So now we are going away from the traditional S3T type data. Here we're talking CAN bus data. So say I'm an engineer and I work for a car manufacturer, and this car manufacturer wants to increase the ADAS level, the level of the ADAS, autonomous driving assistance system, advanced driving assistance system, ADAS, right? There are 5 levels. Say we want to move from level 3 to level 4 and eventually go to the autonomous car, the fully autonomous car. That's our final objective. So my task is to understand how a population of real drivers use their cars on an everyday basis. For that task, I'm getting customer usage data files every single day, and I need a way to process that. So the question is, how do I extract useful information, useful insights from those huge quantities of CAN data? And how do I cope with the fact that this data is not the traditional test and measurement data? It's got space, gaps, and nuts and numbers all over the place. So in other words, GlyphWorks was not designed for this sorts of data, right? So thankfully, nCodeDS can handle unevenly spaced data. nCodeDS natively has options and features to clean up nans and anomalies in that typical in that sort of data, and then you can produce stats, histograms, trends, etc., etc. So now I'm gonna use some CAN data. This data is coming from Peugeot Citroën PSA, so I'd like to acknowledge that. So in this very example, say I want to quantify how often a user exceeds the speed limits and by how much. So the use case here is I do have the vehicle speed as part of the CAN. Another thing you may have in the CAN is the traffic sign recognition, telling you which is the current speed limits, right? The car can recognize the traffic signs, or road signs, sorry, and collect that in the CAN, and therefore you've got a time series of latest speed limits sign, which is quite interesting. So you can subtract those two, and I want to quantify how much a user exceeds the speed limit. Does it happen at all? And if it does, by how much and how often and things like that. The second bullet point here is I want to quantify the distribution of distance and time gap between vehicles. So how does a typical user, how securely, if you want, does a typical user drive? Like, is this typical user close to the vehicle that's in front of him or her, in distance or in time gap as well? That's quite interesting if you're after implementing an autonomous brake system, for instance. So the final objective is we want the autonomous car to produce a similar level of comfort and driving experience as the so to say manual car, right? So let's move to this demo. Let me just get back to my list of apps here. Here I've got this app called Process CSV Files. So the input files are CSVs and typically from the CAN, right? Look at this beautiful DS Citroen in front of the Tour Eiffel here. Anyways, so let me run that now. Now the first page that it's gonna pop up with, it's gonna show me, is somewhat more sophisticated than in the previous demo. Here it's asking me questions to search for files, right? So the CSV files that are in the system were indexed, so that I can now discriminate between the Peugeot and the Citroen and the DS files, for instance. So let's pick the Peugeot 5008. That's the car I'm driving. It's really a nice car, I like it. The drive type, for instance, that's just an example, but you could imagine as many criteria as you wish, right? The model year, so let's pick 2018. Next. So it goes and look for the files. It grabs the files that correspond to this search that I've made, and it's now processing them, and it's producing the histograms I just described. So again, server-side processing. And here you go. That's a result. So that's a PDF that I can open here. That's a report. Let me just see what it contains here. So there you go. You've got your CAN data usage reports. So here it's analyzed 700 kilometers worth of data, 800 minutes of driving time, very, very fast. And I've got my the answers to my questions. That's the time spent below and above the speed limits. So the x-axis showing the speed difference between the speed limit sign and the actual speed that the car was driving. So here we've got, sorry, I'm going fast here. We've got a fleet of cars, right? Many cars, many users, and I've basically concatenated all the data and produced this histogram, right? So you have here, this histogram is showing how much time was spent above, in the positive side of the x-axis, above the speed limits and below the speed limits, right? So we see that it is sometimes exceeded, and we see it is exceeded. I could probably zoom in by 10, 20 kilometers per hour, typically maximum, right? Rarely above that. So that's useful information, isn't it? The other information we've got there is the distance between vehicles. So we see that it's the distribution is half pipe type distribution. So either we are very, very close, that's probably the bumper to bumper type scenario in a traffic jam, for instance, right? Or very, very far away. In other words, there's no one in front of me, and the sensor probably goes to its maximum value. But more interestingly, I guess, it's the time gap between vehicle that we want to see, because this one contains the information of the vehicle speed. So it's rare that we have less than a second between two cars, from that fleet that I selected, but we have a fair amount of time between 1 and 2 seconds. So obviously all this can be customized, the resolution here, etc. So that sort of information can be of a crucial importance if you were to tune some algorithms to make your car more or less, at a higher ADAS level, for instance. So that's it for this demo. Let me just go quickly back to the PowerPoint presentation. Now the takeaways. So we've seen that we processed digital bus data. Those were CSV files. Some of them were quite big, and if we looked at one of them, again, this is coming from PSA. I'm really glad they allowed us to use this data. I've changed those values, obviously, right? But typically, you've got missing data and non-equally spaced time vector here. So nCodeDS can process that data. No need for resampling whatsoever. So nCodeDS is well suited for the analysis of connected vehicle data because it typically comes up with that sort of data. Again, if I had to build the equivalent GlyphWorks flow, then the analysis, the processing would have processing stage would have taken 100 times more processing time, right? So here NCodeDS is 100 times roughly faster, simply because there's no need for resampling the data, simply because it accepts it natively, it has natively all the options for coping with that sort of data. Okay, so let me go back to the main points of Akira. So as you understood it, Akira and nCodeDS in Akira, sorry, it enables you to extract more value out of sensor data. By sensor data, could be any sort of data that you can get from IIoT or Industry 4.0, for instance. It's very powerful, as we saw. It can get 10 times, 100 times faster than the equivalent GlyphWorks process, thanks to its scalable and distributed streamed data processing abilities. And it's included within Akira. So as I showed during those demos, it's very simple to use. You press the play button, you get asked a number of questions, you reply to them, you press analyze, and you get your results. That's it. So you can easily deploy the processes that your experts have built for your engineers to use, and so the engineers can spend more time thinking about actions to take rather than spending time dealing with details and the data and coming up with different answers to their colleagues, right? If you want to know more about nCodeDS, please visit our website under encode.com/nCodeDS. There's a white note paper there, video, things like that, so more information about nCodeDS.